Good evening, everyone. I'm Mona Shrestha from Franz Geiger's group in the chemistry department. I would like to thank you all for coming here to the RSG symposium today. Today I'll be talking about solving a mystery in the atmosphere. How many of you over here have seen a smog like this shown in the picture? Almost everyone. Have you ever wondered what they're made up of? Maybe? Smogs like this are formed by liquid droplets or solid particles known as aerosols, which are found in the atmosphere. When we say aerosol in our daily life, we refer to these aerosol spray cans. But today, I'm not talking about these aerosol spray cans. When I say aerosols, I'm referring to these atmospheric particles which come in various sizes. In comparison to the diameter of a human hair, the largest individual aerosol particle is quite small, as you can see in this picture. So aerosols are very tiny specks of matter which have various origins. Their natural origins consist of sea salts from the oceans and dust from the deserts. Vegetation can also form aerosols, which I'll be talking about more later. Forest fires can send in residual black carbon into the air. And finally, the remaining about 10% of the aerosol mass is from anthropogenic sources like pollution. Hence, aerosols are everywhere in the atmosphere. Once they are in the atmosphere, what can they do? Why do we care? These aerosols can absorb solar radiation and can have a warming effect in the environment. Conversely, they can also scatter light, and then they can have a cooling effect on the Earth's surface. Furthermore, these aerosols may form droplets that may develop into clouds. Despite the importance of aerosols to the climate system, we still don't completely understand how they are formed or what they are made up of. The pathways leading from molecules to molecular clusters and finally to this aerosol involve various chemical reactions which are poorly understood. So you can imagine this aerosol particle as a complex mixture of thousands of compounds in it. So consequently, accurate prediction of these formation pathways and composition of aerosols is hindering how we are going to accurately predict the climate. So it's hindering our climate model systems. So the mystery we are trying to solve is trying to understand how these aerosols are formed. As I said earlier, there are various sources of aerosols. We are focusing in aerosols formed by vegetation, especially formed by this gaseous molecule called alpha-pinene, which is emitted in abundance by these boreal ecosystem. So these alpha-pinene, once emitted in the air, they can react with different substances that's found in the air, and then they can form aerosol particles. So we are trying to understand what happens once alpha-pinene gets into the air, and how does it form aerosol particles. It's not a small project, so what we're trying to do is we are collaborating with people from across the continents in order to shed light into what really is occurring over here. So starting with our collaboration with Thomson Group at Northwestern University, they are an organic synthetic group, so they prepare different compounds. So we have various important reactions that are occurring in the atmosphere. So they're making these model compounds from the atmospheric reactions of alpha-pinene. We also have this environmental chamber. We are collaborating with an engineering group at Harvard University. So this environmental chamber, you can imagine of being like a big 5 cubic meter sized room. We can feed in alpha-pinene and other substances in there. So they are going to react, and they are going to form these synthetic aerosol particles, which will be less complex than what's already out there in the nature. So in order to understand what happens in the environment, we have brought the forest into the laboratory. Finally, we also have researchers in Finland where they have this huge boreal forest ecosystem. So they hold annual field campaigns. They go out into the forest and they collect all of these real aerosol samples. And as I told you guys earlier, that in these boreal systems, most of the gaseous molecules that are emitted are alpha-pinene. So most of the aerosols that are formed here, we are assuming would be formed by alpha-pinene. So we have these proposed compounds that could be aerosol constituents, and we have these synthetic aerosol particles from the environmental chamber. And we also have real and natural aerosol particles from the forest. So what we finally do in our lab is we use cutting-edge laser technology. We try to match. If there is a match between these model compounds and synthetic aerosol particles, or if there is a match between the synthetic aerosol particles and the real aerosol particles. So all we are trying to do is try to pinpoint if there are reactions and any products that are important in the formation of aerosols from alpha-pinene. So working together as a team, we are trying to understand what exactly happens in the atmosphere when there is alpha-pinene available. Finally, we hope to be able to solve a part of this complex puzzle of formation of aerosols by alpha-pinene. And we also hope to be able to provide important reactions and products to feed into the climate models for accurate predictions. Lastly, I'd like to thank my advisor, Franz Geiger, and my group for their continuous support. And I would also like to thank my collaborators who have been playing a huge role with me in trying to unravel this mystery of aerosol formation in the atmosphere. Thank you all.